Hey guys, this is Mr. Torres, as promised, with a quick review for the Quest 7 that is due on Monday. Just gonna go over a little bit about all the topics that we've covered so far. Starting with the first one, dealing with isosceles triangles. Okay, so the isosceles triangle theorem and its converse. So the theorem said the following, that if you had an isosceles triangle, first of all, let's review some vocab. This is a leg, this is another leg, here's the base. The isosceles triangle theorem said that if you had two sides of one triangle congruent to each other, then the angles opposite those sides, angles opposite those sides would also be congruent. Okay, so if I have triangle ABC, what it's basically saying that if AB was congruent to BC, then angle A would have to be congruent to angle C. Okay? And then the converse basically said that, but backwards. It would say, hey, if I have the same triangle and I said, hey, if angle A is congruent to angle C, then you can also conclude that side AB is congruent to side BC. Okay? And then we did a couple different problems. If we had a triangle, and I say, hey, this triangle is an isosceles triangle, and you have, I don't know, this angle is, and in reality, if I gave you this angle was 110, that's all you would need. Because if that's 110, another vocab review, these two are a linear pair, so therefore they're supplementary. So 180 minus 110 gives me 70. So this angle right here is 70. And because it's a base angle of an isosceles triangle, then this angle right here would also be 70. And 70 and 70. So to find that angle up here, which again, my screen just messed with me and gave me too many triangles. To find that angle up there, I would just go ahead and say, okay, well, 180 minus 70 plus 70 is 140, so minus 140 gives me 40 degrees. So then that angle would be 40 degrees. Okay? And all of that from knowing that angle on the outside. If I just knew that angle on the outside, then I would be able to find the measure of all the other angles. Okay? Again, if I knew this one was 110, then this one would have to be 70, 70, and 40. Okay? Don't forget, if you have triangles with angles that are vertical to each other, same rule applies. You know, if I get this one is 50, and this is 50, so then this would have to be 80, so then this would have to be 80, and so on and so on. All right. So then from there, we covered similar triangles. Okay, and for similar triangles, we had that in similar triangles, we would prove them similar to each other by one of three different ways. We would prove them similar to each other by one of three different ways. So the first way to prove them similar was side-side similarity, which in reality, if these two triangles, triangle number 1 and triangle number 2, are going to be similar by side-side similarity, then that would mean that their sides would have to be proportional. So if this side, I don't know, let's make it 2, 3, and 4, then this would have to have the corresponding sides would have to match in some way. Okay, so that 2 over 6 should be the same thing as 3 over 9 and 4 over 12. They all give me a scale factor of 1, 2, 3. Since they all give me the scale factor of 1 and 3, then they are similar by side. similar side. Okay. For side angle side, you have to have something that looks kind of like that. Okay. But they have to also give you the measure of an angle, and the angle would have to be what we call the included angle. So in this case, it's not the angle between two congruent sides, but between two proportional sides. Okay. So yes, I still have 2 over 6 equals 3 over 9. But now I also have that angle A equals angle B. So the triangles are similar by side angle side similarity, because I still have two sides that are proportional and the angle in between. And then angle, I feel like was the easiest one for you guys to comprehend. For that one, we had I'd have to have two angles of one triangle congruent to two angles of another triangle, and that would give me angle similarity. Sometimes they didn't give you the measure of the angles, and they just said, hey, this angle is 40, this one is 80, okay, so then this one is 60, and that one is 40. Are the triangles similar? Well, your initial reaction is to say no, because I only have one angle per triangle congruent, but in reality, if you do some math, you would do 40 plus 60 is 100, so 180 minus 100 gives me 80. So this angle would have to be 80. So in that case, those two are also congruent. So yes, the triangles would be similar by angle similarity. Okay? And then once we used that, once we said, hey guys, we have similar triangles, and these similar triangles that we are labeling similar would also, those properties of similar triangles, the properties of those similar triangles could then be used for indirect measurement. And there were 4 different types of indirect measurement. We talked about the shadow problem. We talked about the mirror problem, so the mirror on the ground. Talked about some kind of like bow tie, and then triangle and a triangle. So the shadow problem was, here's a certain person, here's a building, the sun is somewhere up here shining on them, and it casts a shadow, The shadow from the guy is, I don't know, make it a number, size feet, 5 feet tall, 5 feet. He is 6 feet. So how tall is the building if it's casting a shadow that is 55 feet? Okay. So then I would have to say, hey, height over height equals shadow over shadow. And this type of proportion is everything you're gonna want to that proportion is what you're gonna want to write for all of these, the corresponding parts. So you would do, hey, 6 over x equals 5 over 55. If you can reduce it and you know how to reduce it, like for example, 5 over 55 is 1 over 11. If you can reduce it and you know how to reduce it, go ahead and do it, and then cross multiply, or go straight into multiplying. Okay, x in this case would have to be 66, because if I simplify this into 1 over 11, 6 times 11 is 66. Okay, and again, that's how you would do all of them. Like the mirror on the ground. So let's say that here's the person, here's a tree, and the person places a mirror on the ground so that they can see the reflection of the tree on it. Like I said in class, the mirror would have to be in between the person and the tree for them to see the reflection on the mirror if the mirror is on the ground. Okay? So you just always have to draw these triangles. Okay, draw these triangles. And again, you're going to go with height over height equals whatever, this in this case distance over distance. So if the guy is 8 feet from the mirror and the mirror is 14 feet from the tree, he's still 6 feet tall. How tall is the tree? So you would do height over height equals distance over distance. And if I'm starting with the 6 on the top, I have to use the number of the same triangle on the top as well. If I wanted to start with, I don't know, with x on top, then on the other proportion, the other ratio, then I would have to start with 14 on top. Okay. All of these are equivalent to each other. You just have to know how to do that. Then you had, what was the other one? The bow tie. And the bow tie looks something like this. Bye-bye tree, I guess. The bow tie looks something like this. Okay. Remember, you're gonna have vertical angles. You're not gonna mark them congruent, but you're gonna have vertical angles. That's part of what proves them congruent. Okay. And let's say that, this distance is, I don't know, 80 feet. You're trying to find that, and they give you one other distance. Let's say this is 30, and this is 60. So 80 over x equals 30 over 60. You're going to have a lot of proportions, guys. A lot of proportions. Just make sure that if if you pick something from triangle number 1 to go on the top, then the other part of triangle number 1 also needs to go on the top. Do not, and I repeat, do not get in the habit of doing this, because more times than not, that will fail you. Now, this is written correctly, but do not get in the habit of doing that, because what I see a lot of students do is, okay, 80 over 30, so then that equals 60 over x. Now, that one is correct. That one is not right. That's why I don't want you to get in the habit of doing that. So make sure that you don't write it like that. Just do the parts that correspond to each other, put them in one ratio, and then the other parts that correspond to each other, put them in the other ratio. Okay? And then for the triangle within a triangle, the most important part was understanding that, hey, this angle is shared by both triangles. Okay? That angle is shared by both triangles. So if I give you, if you're trying to prove triangles similar, you have to remember that. But for this part, you already know they're similar. So just remember that if I've labeled this as like, I don't know, 20, and then this is D, and this is 40, and this is 50, then when you separate the triangles, you have a triangle that says 20 and 40, and the larger triangle says 50 here, but what's the length of this side? It is not 20, and it is not D, and no, it's not 20D. It is 20 plus D. Okay? Again, it is 20 plus D. And that matters, because now my proportion is 20 over 20 plus D equals 40 over 50. Okay? So those are the indirect measurements. And then we had the mid-segment of a triangle, which connected two midpoints. The mid-segment connected two midpoints, and it was half of the opposite side. So if that was 10, this would be 20. And not only was it half, but it was also parallel to it. So parallel, that would mean that you would have corresponding angles, or you would have same side interior angles. Okay? And then the last day and a half, we've been talking about the Hinge Theorem and the triangle inequality. Longest side is opposite to the largest angle. The shortest side is opposite to the smallest angle. Okay. Look over your notes. Good luck. Have a good weekend.